Again, good afternoon to all. So our topic this afternoon is diode application circuits, particularly in diode wave shaping applications. So far, what we have discussed are series and series parallel diode circuits, of which ang voltage sources are DC, or the direct current voltage sources. So examples of mga DC sources are batteries, solar cell, so pa ba? Chargers, no, power supply, and all the other DC sources. Now, katong mga nanga-solve bitaw na to na mga circuits, actually those are more trivial kind of circuits, no? We could not determine yet based lang sa first na look sa mga circuits kung unsa siyang klase nga application, no? That's why contented lang ta sa pag-solve sa currents and voltages and DC sources of pagyod. So what if ang voltage source, or in this particular case, ang signal source is not anymore DC, no? What if AC siya? What do I mean when AC, or alternating current? Maybe ang source is a sinusoidal wave, or triangular wave, or square wave, no? So those are examples of alternating current na sources, or signal, alternating current na signal. Or what if random siya, no? Like voice signal. So these circuits na atong ma-discuss this afternoon will be dealing particularly with those kinds of sources, those kinds of signal, alternating current signals. So we'll start with this one, the half-wave rectification, or half-wave rectifier. Okay, so the diode only conducts, or half-wave rectification happens when the diode only conducts when it is forward biased, therefore only half of the AC cycle passes through the diode to the output. Okay, so zoom in lang ko doing a part. So remember that the main function of a diode is the switch, right? It conducts current in only one direction. Meaning, kung saang direction sa current na mo coincide sa direction sa diode, ay siya magpapass through current, no? So what about alternating currents, where ilang signal is composed of two parts, no, or two types? One that is in the positive cycle and another in the negative. So the most basic alternating current signal that we have is the sinusoidal wave. Okay, sine wave. This is an example of a sine wave, no? Two periods of sine wave, where these points sila are the peak value, maximum value. Let's call them VM and negative VM. So this seems like magnitude. So if this is 5 volts right here, negative 5 volts. We all know about sine waves, even way back when we were learning trigonometry. So what if yan ang atong input signal, not anymore DC? So this is an example of a voltage source with respect to time of an AC signal. So they choose as a DC signal. A DC signal is just a constant na valued signal. Nga lang, no? Constant. So if this is a 1.5 volts battery, that is 1.5 volts. So if this is a 3 volt battery, this is 3 volts. It's 3 volts all throughout. No? So not doing 0, put it on 0. So unlike the DC source, ang AC source is not only mag-fluctuate, but mag-increase and decrease in value. So again, what if ang atong maximum voltage value is 5 volts positive and negative 5 volts negative? So from 0, mag-increase siya value up to 5. No? So 0, 0.1, 0, 0.1, 0.2, 0.3, 1 volt, 2 volts, 3 volts, 4 volts, di ba? Mag-reach niya yung 5. Di mo balik na po siya 0. 5, 4, 3, 2, 1, 0.9, 0.8, tama 0. And negative na pod. Negative 0.1, negative 0.2, 1 volt, negative 1 volts, negative 2, negative 3, negative 4, negative 5, and so on and so forth. So muna ihang behavior. Okay? That's how sine waves work. So what if this kind of signal ato ipapass through sa diode? And the diode circuit that we have looks like this. This one. Or ako lang sa iritlo daan. Muna yung atong input sa atong circuit. So, basically, wala na siya ground kay AC sources, wala may ground. Ang symbol for the AC source is this one. Sine gap, no? Sine wave. So, this circuit, a very simple series circuit, but if AC signal ang i-feed sa itong circuit, this is not anymore called a simple series na diode circuit, but we call this one as our half wave rectifier. So this is the simplest circuit that we could come up using a single diode and a single resistor in series. No? Wala siya kalahian. No? There's nothing different from this one and a simple series diode circuit. Ilan lang difference siguro is ang atong source or signal source. AC man nga source. But because AC ang source, its name is a half-wave rectifier. Sometimes nga yung tawag sa diode is a rectifier diode. Because kung i-connect lang nato siya isa ka series nga resistor, ang pwede na niya mabuhat is rectification. No? So rectification is the process of this one. No? Nalagay ang definition of rectification actually. The passing through of the signal of the one half of the AC cycle of the signal source. No? One half lang pag yun, no? The other half lang, or the first half actually. So if this is the input, okay, ito ikuan ha. So muna itong circuit, muna itong signal source. Ito na gamitin ng images na nasa slide. So na doon na-connect ang itong source. Muna. So for the positive cycle, muna itong given, red na lang, no? The positive cycle. Ano? Any value from 0 to positive 5 volts is of course positive, di ba? So 0.1, 0.2, 0.3, 1 volts, 2 volts, up to 5 volts, they are all positive. Now, because they are positive, i-allow ni diode na mo-pass through sila. Or at least sugod sa 0.7. So during the positive half cycle, si diode is mo on. No? Mag-conduct si diode. So, ang itsura sa output signal, or what we could find in the output, is exactly the same lang sa source. No? Kaya lang, no? There's nothing different. This one. Size as red sa source. Siya. So, pass through lang niya. Actually, ang kakitabo gid ani is ideal diodes ang gi-use so far sa kaning discussion right now. So if we're going to use the practical ones like the 0.7 type of silicon diode, aya pa gid na siya mag-pass through pag 0.7 na ang kuan, no? So if mo yung signal, let's just say 2 volts ni sila. 2 volts ang peak ani nga signal. 2 volts and negative 2 volts. So, 1 volt is somewhere here. Most probably. At yung 1 volts. 1 volt, I mean. So, 0.7, maybe na-adire. No? Na-adire ang 0.7. So, ayahan lang si diode mag-conduct if ma-reach na ang 0.7. No? The same with yapon sa atong analysis before. So, itsuraan ni sa output is blank na diha or 0 before 0.7, and once mag-hit check 0.7, ana. And once magbalik og 0.7, pag abot og 0.6, 0.6, 0 na po na siya balik. Supposed to be nga na ang atong output signal. If we're going to use the more practical diode model. So more practical ni siya. This one is using the ideal diode. No? And siguro for the remainder of the discussion, we're going to focus on using the ideal diode lang. So ideal is di na nato gina-consider ang voltage drop na 0.7. So VD is 0 volts when conducting. That's why here, nag-conduct na siya diretso at 0 volts. No? Wala na niya gihulat ang 0.7. We're using the ideal conditions where the diode is a pure na switch. So for the practical one, na itong gigamit so far, where VD is 0.7. Yan na. So that's for the positive half cycle. The red portion sa atong input signal. What if sa negative part? What if diha? No? So from negative 0.1 to negative 0.2, up to negative 5, then back na po to negative 4, negative 3, up to negative 0.1 up to 0. So ang direction sa atong diode, or sa atong current, I mean, sa signal, is this one. That way. Muna ang direction sa current at the negative half cycle. Ana. So pagbalik sa purple nga current sa 0, red na pod, then purple na pod. Ana. So red, purple, red, purple. Try to observe. Sa negative half cycle, or sa direction sa purple nga current, what is the condition of our diode? Is it forward bias or reverse bias? Hello? Sige. Type 1 kung forward, type 2 kung reverse. Sa chat. So, 1, 2, 2, 2. Okay. Kung sa siya thank you guys sa response. Kung sa siya mag-2 or mag-reverse bias kung dili mag-coincide ang direction sa current sa circuit and iyang own direction. So, in this case, dili sila mag-coincide. Ang direction biya sa atong current sa diode para ma-forward bias is that way. And ang current sa negative half cycle, which is the purple one, mubangga siya, no? So, reverse bias. So, equivalent circuit ani is this one. So, short circuit, na open circuit. And because open circuit, no current will flow, 0. Diba? So, 0 siya. Unang negative half cycle, this one. So, 0. So, kung ato ning i-summarize tanan, if our signal source is an AC signal, so no need for analysis, madurora na to sa iyahang output. In actual, ma-measure ni siya with the use of an equipment that we call an oscilloscope. So, itsura sa atong signal would be like this. So, half-wave rectifier because only one half lang sa input signal yung ipapass through. Okay? The DC output voltage is 0.318 VM, or the maximum value, where VM is the peak AC voltage. Maximum value of peak. Pareha lang maximum value of peak. So, kung ani gikan ang 0.318 nga i-multiply sa maximum value, na-obtain na siya using calculus, so din na ito i-derive. We'll just take note of that one. What does this mean? Remember, ang atong original na source is AC. AC source. If ipapass through ni siya sa rectifier diode, actually, ang kakitabo is na mo gawas, no? Nanay ma-make apparent na DC voltage, DC source gikan sa ato ang AC na source. So, although not perfect, but na-transform na siya. At least this is the first step. Na-transform ang ato AC source into a DC source. So, if you have heard of devices such as an AC to DC converter, rectification is the first step. That's not the only step, of course, but that's the first step towards converting an AC signal to a DC signal. Okay. So ang 3.18 multiply natin na sa maximum voltage. It's as if we have a multimeter, no? Kung natay meter na naka-set sa ang DC output voltage is this one that I'm explaining, no? DC output voltage is the voltage that we will obtain if we have a multimeter, no? This is the one that is measured by DC voltmeter. So if natay multimeter na naka-DC mode then i-measure, buta na to dire sa atong circuit, we would obtain a value of 0.318 times VM. No? So example, natay 5 volts na AC signal. Let's say natay 5 volts na AC signal. I-multiply na to 0.318. Pili mo guys na answer. 5 times 0.318. It's 1.59, no? You could type it in your calculators. So, ang 1.59, muna siyang ma-measure sa atong DC voltmeter. So, if we do not have a DC voltmeter and we want to obtain the value of the output DC voltage, we could use this formula. So before I proceed, I have a question. So before I proceed, I have a question. I mentioned earlier that this rectification, this process is the first step in a much larger process of AC to DC conversion. No? Now, have you heard of this type of device before? An AC to DC converter? Insay nakadungog na. Type 1. Hindi ka sure? Sige lang, kaya. But I would like to contend na I'm very sure of this 100%. Itatanan dire na igani nga device with us right now. Kung dili man galing with us right now, siguro nasa somewhere sa balay. So this is a very common device. If wala ni, we will not be having this online class right now. So unsa man ni siya? Do you have this
Power
device
supply
with you? Power supply, yes, power supply. Medyo technical na siya nga term, pero that's correct, no? This is a power supply. Unsa ang more practical nga device, no? Nga pwede na itong ginagamit. Power supply, technical man na siya. That's a general term for an AC to DC converter. Naay device nga ani nga sure ko gigamit gid ninyo siguro for the past. Kasi ginagamit kayo ninyo karon? Cellphone. Cellphone what? Ang cellphone mismo, wala man siguro yung AC to DC converter sa sulod sa cellphone.
charger, sir.
Charger, very good. So, kanang atong charger is a more practical, di ba? More layman's term nga device, nga pangalan sa kaninga device, no? So, ang very technical term nga dili kay ginagamit, no? Actually, wala man ginagamit ang term nga AC to DC converter gyud. So, sakto tong kanina, power supply ang more technical term for AC to DC converter. Pero more practical nga term is charger. No? So, ang atong input sa atong charger is gikan sa atong wall outlet na 220 volts AC, i-convert na niya into a usable. No? The cellphone could not directly use the 220 volts. Saksak ninyong battery sa 220 diretsyo, buto na, di ba? I think common sense man siguro na siya nga kuan. Pero ay magamit sa battery sa battery sa cellphone ang 220 kumagi sa siya og charger. So i-convert na niya into 5 volts. I think 5 volts man tanan batteries na to karon, except siguro sa laptop. So actually the ulo man, no, the ulo lang sa charger ang power supply. Ang wire technically dili naman gina necessarily power supply ang wire kanang atong USB ba cord ba ka or type C nga cord, no. So ang ulo lang actually, no, sa atong charger mo na siya ang AC to DC converter. And again, the first step sa process sa pag-convert from 220 to 5 volts is rectification. So half-wave rectification, or at least ang rectification is very important to us, no? So walay practical electronic circuits or devices we could use if not for this process, no? Very simple one. But it's not the half-wave rectification actually nga gina-utilize sa modern power supplies. It's the other one, It's the full wave rectification. So full wave rectification is the same sa half wave rectification. Ang ilang difference is dili lang kay ang first half ang ipapass through but also ang second half. But much more than that, no? If we have a half wave rectifier, natay AC signal here, ang output is na, no? So what about if full wave rectifier siya? Ipapass through man daw niya ang both cycles sa signal. So this is a full wave rectifier. So again, if this is our input signal, so suligar itsura sa output, sir. Nga nagyapon, ipapass through mo daw niya ito na. Dili. So ang positive, ipapass through niya in the same way sa ginaon sa pag-pass through sa half wave rectifier. But na something wonderful may tabo sa negative half cycle. Dili lang kay ipapass through niya, no? Dili niya isuppress, ipapass through niya, but ipapass through niya, it's as if positive ang signal, no? So yan ang itsura sa output sa full wave rectifier. Okay, ipapass through, dili lang kay ipapass through niya ang all cycle sa signal, but ipapass through pod niya in a sense nga i-flip niya in a positive na direction ang negative half cycle. Okay, so in a nutshell, that's how full wave rectifiers work. Now we have two types of full wave rectifiers. Wait na sa There are two types of full wave rectifiers. We have the bridge rectifier and the center tap rectifier or center tap transformer. So we have the bridge rectifier and adapter, no? Sakto adapter. Bridge and center tap. VDED ba to? Center tap transformer rectifier. So both work the same way in terms of functionality, no? Kung bridge rectifier is yang output niya na lang gihapon, ang center tap niya output ang gihapon, no? So like alayan. In terms of itsura, of course, circuit na So what does a bridge rectifier look like? It looks like this, no? And for me, I think almost all modern electronic power supplies use a bridge rectifier na configuration, no? So if ato ning i-withdraw, then mo ni atong AC signal, pareha ni sila kung yani ang pagka-drawing, no? So this is a bridge circuit. So kani kato pareha. Just try to bend, no? Use your imagination na lang. Try to bend the diagonal na wires. Kani is pasaka siya, kani panaog. Kani panaog, kani pasaka. So pareha na sila. If makita tag other circuits exactly the same configuration, that's called a bridge circuit. So why is it then ng output sa atong signal is like this, no? Like that. Nganong dili man kuan man kaha, sir, ipapass to man kaha na both nga cycles. Nganong dili man ingana, no? Sine wave na siya. Anong ang negative half cycle is flip siya. So mo ni positive, mo ni negative half cycle originally, nga na positive na. Okay? So I'm going to explain right now. So where will this be measured? No, asan ni siya i-measure? This will be measured from the load resistor. So based sa circuit, the load resistor is that device in the middle of our bridge circuit. So this one. No? And normally, dire gina-connect ang ground, no, sa atong resistor. And because diha ang ground, na diha ang negative, this one. No? So na diha ang negative nga terminal sa atong resistor. So if na diha ang negative, because na diha ang ground, nagdi ang positive. So we will measure our output voltage with that kind of reference. This one as the positive, this one as the negative. Okay. So for the positive half cycle, this one, the diode will go in this direction. It goes from the source. Remember, AC atong source sa dili DC. So mubalik na siya sa DC source. Dili na siya mubalik, dili na siya mo ato sa ground. So it goes from the source, going in that direction. No? Dili siya mo kaagi dili kay block man siya. No? So the positive half cycle will be blocked by diode D1. No? So our current will flow in the direction only kung asa i-allow ni diode. Di siya makaagi diha because block man siya ni diode. So there's no other way but here. And then mo pass to siya kay resistor. Ang pagpass to niya kay resistor from positive to negative light. So in line lang sa direction sa current sa atong source. So di po siya moagi kay D4 kay i-block yapon siya niya. So again, there's no other way but mulaw siya kay resistor and moagi siya kay D3. And then balik siya sa source. Balik siya sa iyong origin. Wait. Negative now. So muna ang positive, that's why well, pare naman ang pag-pass through sa positive half cycle sa full wave o half wave. Now karon ang tricky part sa negative half cycle. No? This one. So magikan siya here. So negative nga part sa AC signal. And then dili siya moagi kay D3 because the same sa kay D1 ganina sa positive half cycle, block po siya ni D3. Block siya. So di siya moagi diha. Di siya moagi kay D4. After passing to D4, di siya kaagi kay D2. Kay block gyapon siya niya ni D2. So mulaw siya kay resistor. Mulaw siya kay resistor. And notice, ang pagpass to sa negative current sa load resistor is the same sa pagpass to ganina tong positive, di ba? Tanawa ang red nga arrow, padlong dito. Ang purple nga arrow, padlong po dito. That's why, relative to the resistor, the same ang signal ng pass to sa iyaha sa positive half cycle and sa negative half cycle. So, ato lang na siya dito to D1, then balik na siya sa source. And that's it. No? So, for the positive half cycle, muna itong signal. For the negative half cycle, muna itong signal. Okay? Ano, dili gani oh. Ada sa silong slide. So, ang difference niya, aside sa output waveform, ang difference niya sa half-wave rectifier is the value of the DC voltage. So tungod kay duha ka diode ang iyang i-pass through, i-times 2 lang tong 0.318. So 0.636 times Bm. That's the value of the DC voltage. So that's for the full wave na bridge rectifier. For the full wave na center tap, same gapon, naman gapon the explanation. So for the positive half cycle, di mo agi ang atong current. For the negative one, okay. So in effect, pareha siya sa bridge. Of course, full wave rectifier man siya. Expected na nga parehas. So asa sa nag-differ? In terms of DC voltage value, the same gapon sila. 0.636 gapon. So nag-differ sila in terms of the peak inverse voltage. Peak inverse voltage or peak reverse voltage. Pareha na sila, PIV or PRV. What does this mean? Because the diode is only forward bias for one half of the AC cycle, it is also reverse bias for the other, for that one half cycle. No? So for example, i-explain lang nato ng peak inverse voltage using the half wave rectifier. But same like ang concept when it comes to the full wave rectifier. So balik ka dire. Dahil naman kayo kulis-kulis. No? Gawin na lang kong lahi. So half wave rectifier is just a simple AC circuit. A simple series circuit ng AC ang source. Yan na. So muning input na to, muning output. So for the input, so yung output, na, ba? So what is peak inverse voltage? During the positive half cycle, during the conduction of the diode in that direction, our diode is forward bias. But during the conduction of the diode in the reverse direction, the diode is reverse bias. Okay? Forward bias siya. Dire. Reverse bias ang diode sa negative half cycle. Reverse bias. Now, the idea here is the diode will block that current as long as ma-withstand niya ang value. No? So what does this mean? Tingnan na natin ingani. No? So, let's say for example, our diode is 100 volts positive and 100 volts negative sa Pica's direction. Negative 100 volts. So believe it or not, ang 100 volts nga positive, because forward bias siya, ipapass through lang niya, no problem. But it's not always the case sa negative half cycle. No? It doesn't mean, it doesn't mean that the diode can pass to this value, the positive cycle. It will always allow the negative value, no, sa other cycle, no. Dili necessarily ana ang case. So it might be nga dili lang kay i-block niya, no? It's not only that the diode will block this value of voltage, but most probably maguba ang diode sa kana nga value, no. So there's a maximum amount of value that the diode could withstand in the other direction. So I think that's a better na definition. No? Ako lang itong definition siguro, so that will work. Peak inverse voltage is the voltage value that the diode can withstand in the reverse bias. Mode. Nabanin siya sa DC value na no? Nagyapon. So example, natin DC circuit. Normal na maguna itong handle nga cases is usually 10 volts na siya or even 100 volts. Positive na, no? So, even 100 volts na siya, mupas to lagi po na siya nga value nga current sa atong diode. Again, not so kung negative. Kinanglan at usang tanawon kung ma-withstand ba niya. So, where could we look for this one? No? This can be obtained from the specification sheet. The specs sa atong diode. Okay. Because the diode is only forward bias for one half of the AC cycle, it is also reverse bias for the other half cycle. It is important that the reverse bias breakdown voltage rating, this one, this is the PIV or PRV, be high enough, no, to withstand the peak reverse bias AC voltage. So whatever is written on the specification sheet, that value should be greater than our expected signal source VM. Okay, so wala ng idea here. No? Same goes for the full wave rectifier. So for the half wave and the full wave rectifier, we should always check if the peak inverse voltage from the specification sheet is high enough as compared to the expected maximum value of our AC signal. Okay? Dali naman na masabtan ang kanang idea. So that's where the bridge rectifier and the center top bridge full wave rectifier and center top full wave rectifier differs. No? So although hindi mo to kinang formula, no? Ipangitaon lang mo to sa specs then compare lang ang values. So these are the formulas that we'll be using to compute for the DC voltage. Again, the DC voltage is the voltage that will be measured by our voltmeter in DC mode. These formulas are used. Parehara ang sa bridge use center top 0.636. So ang 0.318 times 2 lang na siya, munang 0.636. So kani kung ideal diode. Again, when the diode voltage is equal to 0. But what if we'd want to consider the voltage drop of our diode, of our silicon diode? So dapat ato ikon ang 0.7, no? I-take into account. So these are the formulas. I think sayop ni siya, napa ni siya bracket dapat dire. Same goes here. So notice naka times 2 ug 0.7 ang sa bridge, ang center top wala, no? Wala times 2. because duha man ka diode ang i-pass through for each cycle sa bridge. Center tap isa labiat. Kung wala ang correct na formula, dapat na may brackets diya. Okay? So before I proceed, any questions so far? None so far. Okay. So if you have any questions, good, no? Particularly kung mag-review na mo sa atong recorded na video, pwede naman mo mag-ask sa anytime. And ang slides available mo po sa e-learn. No? So for me, this is one of the most useful, no? One of the most practical na wave shaping applications of our diode. No? Very simple, yet very useful in our modern day and age. Tanan siguro nga adapters or power supplies mag-require gid og rectifier circuit. So there are two other wave shaping applications of diodes na of importance pod. Not so common but important nonetheless. We have the clipper circuit and the clumper circuit. Okay, so natay clipper, ug natay clumper. No? So, what's the difference sa duwa? So, ang clipper, the diode is in a series clipper, clips any voltage that does not forward bias it. No? So, what does a diode clipper looks like? No? Or unsa ang pinaka-simple na diode clipper circuit? This one. Malaman na lagi nagkuan. Half-wave rectifier. Yes, because a half-wave rectifier is an example of a clipper circuit. Ang full wave, dili naman, kay wala. If you notice, sa full wave rectifier, wala may na-clip away, di ba? Wala may natangtang. For the half-wave rectifier, na-clip away ba itong kuan, negative half cycle. So, a half-wave rectifier is an example of a clipper circuit. But there are many other clipper circuits now that we could build or we could create. No? This is just a simple one. No, so if ang atong signal, input signal is sinusoid, ang output is that one, no? Wave. If atong signal is square wave, just like this one, clip away ang negative half cycle. Same for the triangular wave. Okay? So, daghang klaseng nga mga configurations that we could create for our clipper circuits. One addition is we could add voltage source in series sa atong diode. So again, ang atong signal source here is an AC na signal. Ang i-add nato diri is a battery na DC. So AC ang source. Atong i-add is DC. So what does that do? Okay. In this particular case, it increases, no? It increases. Kaya kung mag-KVL ta dire, wala mong gilain way to explain what's happening here, but to use KVL. If mag-KVL ta in that direction, sa other direction, so no need na because maklip man na niya, no? No need to explain the other half cycle because maklip na niya away directly. Sa positive half cycle, not only gipa-pass through niya, but na ay plus 5 volts. Diba? So kung mag-KVL ta dire, it's VM, the AC source, plus 5 minus 0.7 minus VO is equal to 0. So VO is the VM plus whatever value is ang atong DC. Just like here, mas nisaka og 5 volts ang atong output. 5 volts. Okay? So nalaman dahil gapon explanation sa silong. So kung parallel is a different story. No? So dili na ni siya rectifier, no? So this is not anymore a rectifier circuit. This is not anymore a half-wave rectifier actually, no? So nabaylo lang tungod ang lugar na baylo, sir, dili na lugar siya half-wave. Yes, if ato i-consider na different na ang atong VO, no? This case, ang VO is na measured na across the diode. Sabi tao, ang VO measured na sa diode, hindi na siya measured sa resistor. Kung dili gyapon nato i-measure ang VO, the same na ito makuha sa earlier. Pero ang VO nato karon is sa diode. No? So for the positive half cycle, the negative. Diba? So for the positive half cycle, obviously, diode is forward bias. Okay? But, tungod kay ang atong reference now sa atong output is across the diode, for an ideal diode, pila gani ang voltage drop across an ideal forward bias diode? Ideal, okay? Forward bias diode. So voltage drop is equal to 0, diba? Or kung practical ni, this is 0.7. Pero ideal man itong gisgutan sa, that's 0 volts. So if 0 volts ang voltage across the diode during forward bias, 0 volts so 0 day ang magawas diha. No? 0. During the negative half cycle, diode is, of course, reverse bias. And if reverse bias, open. If open, no current will flow sa resistor, I equal to 0. Unsa naman ang ma-measure ni VO? VO, so diode is non-existent, resistor is non-existent. What it will measure will be the voltage source, which is producing the negative half cycle. So muna siyang output waveform sa kaninga klase nga clipper circuit. So if square wave, na-clip away ang positive half cycle, no? Ironic siya, and napapass through ang negative half cycle. At technically, wala nag-pass through, no? No, sorry. Dili pass through ang proper nga term. Okay, wala man gina-pass through ang current sa negative half cycle. But ang na-measure ni VO is ang negative half cycle. So the same yung triangular wave. So for actual forward bias diode, of course, VD is 0.7. Instead nga 0 ang red, it will start here. No? 0.7. So dili siya sa 0 magsugod. But sa 0.7 siya magsugod. Yan ang may tabo. Kung actual practical. So here is a summary of clipper circuits, series, parallel with voltage sources. So kung yan ang configuration class, no? Pwede naman natin i-refer sa table, no? No need to memorize this one. Just refer to it at lang i-locate kung asa siya nga klase nga clipper circuit. Now for example, this one, no? This one. Kaning nga clipper circuit na resistor, then naka-series ang diode, then naka-series ang DC source na plus minus. Yung negative is nasa ground. So diretso, no? Ang direct na answer ani is we'll just draw this one and just add labels. Kung pila ang value sa V, this one, let's say for example, V is 6 volts. Ito na label here. This is 6 volts. And that's it. No? Kung pila ang value sa atong AC source, kasi atong our AC source is 10 volts plus minus. So 10 volts na ni siya. So this is negative 10 volts. It's just as easy as that. We'll just locate the clipper circuit and label the parts based sa given. So, yan na lang. Explanation noon is ato namang na-cover earlier. This one and that one. So, no need to individually analyze each circuit. Para lang sa explanation to nan. Ang kana nga mga waveforms, each of these waveforms were derived using KVL. So KVL lagay po na ang gigamit pag derive ano nila. So it's enough for us to know the explanation behind clipper circuits na din natin sa okay. Padire kung kulang pa to nakapadire. So ito lang pangitaon asa sa atong summary table ang type of circuit. Last example, what if kani? What if nga ang given? Natay AC source na plus minus 20 volts. Natay battery in this configuration. Ang positive nga portion sa battery is connected sa positive sa diode. No? And atong battery is 3 volts. So we'd expect sa output ang maximum value in the positive half cycle is positive 23 volts. So naman dito, PM plus B. Sa negative half cycle, 0. Okay. So ato lang sundon, no? Ato lang sundon ang mga recipe, no? So to speak. Before I proceed, any questions? So mark ang given ani bitaw class kay given tag circuit, no, malagyan ni. Given this circuit, draw the output waveform. Ato lang pangitaon asa siya sa summary table, then i-draw lang ang iyang waveform. Ana. I-label lang dahil natong value kung pila given. Kung given nga VM is 15 volts, then ang given nga V is 1 volt, so 15 minus 1, that's 14. So negative man siya, so negative 14. So it's just as simple as that. So clipper circuit clips away a portion of the input waveform. So how about the clumper circuit? So clumper, a diode and capacitor can be combined to clamp an AC signal to a specific DC level. So clamp may be a more karaan nga term siguro sa mga nagngalan-ani nila. So another more relatable term is the shift, no? Shift upward or downwards. Yan na lang. Without first analyzing clumper circuits, let's say this is a clumper circuit. Wala pa takabaluhaon sa iyang ang sulod sa atong clumper circuit. Let's say given taog again AC source. Ang output ani would be one of these two possibilities. It could be nag-shift siya upward or downward lang. So if this is the 0 volts or origin, it's as if lang yung origin is ni shift upward po or downward. No? So pwede siya nag-shift upward or nag-shift siya downward. If that's the case, diyan na magsugod og start ang atong AC signal. Dili kay necessary nga ko ano, pwede ganyan siya malampas. Ana. Or nag-shift siya downwards. Yan na lang. So that's how clampers work. So how does it do that? With a combination of a diode and capacitor, in many different manners. For example, kanil lugar, usay mo gud ang visual sa slide kay misleading, ay kanang confusing, no? Not really misleading. Correct man siya, accurate man siya. Pero yung pag-shade, I think nasa shading ni siya. Dili kayo helpful ang yung pag-shade. Eh kung atong tanawon, if mo na yung original, dapat iyalang gi-shift upward or gi-shift downward. Sa kaning example, if mo na yung original nga origin, na shift lang ang origin actually downward. Ano dire. So, ignore for the moment ang shading na blue, no? Ignore lang ang blue nga shading. Nara na atong signal, So, nag-shift lang siya downward actually. Padayon lang man dayon na. Supposedly dapat mo-on niya ang gi-shade, So, para naman good, no? Wala niya nigi-shade kay wala man po ga-exist din nga kung kuan pa power level, no? So ano siya issue la. Just like this one, So here, this is a pure capacitor, diode, and resistor. Dire, ang atong diode is nanapod siya naka-series nga battery, no? Pero still, the same gyapon og use. Okay? If originally, nadire ang atong origin, karon na siya sa taas, so nag-shift siya upwards. Might be here. Ano itong signal? Ginuwag, aside na shift siya, ginuwagan pag niya o adra plus 10. So, gi-shift niya, instead nga 20 man no? So, 40 magyapon. 30. Okay, this is good. Ang glowing. So, nadiha. Sakto. Akong glowing sa iyo. So, nag-shift lang siya upwards. So, yan na lang. Same gapon. We have a summary table of different kinds of configurations for clamper circuits. Again, clamper circuits will be composed of capacitors, diodes, resistors, and batteries. So, kung sa combination ana, pag mix-mix, ano na sila nga klase ng mga circuit. Diba? So, ito ng pilion, no? May tao nasa. Again, ang shading might be confusing. Pero nagyod ang original nga signal kay kung mo yung original nga signal, niyara siya. No? Here, shift upward. Dire, ni-shift downward. Dire gani dili kayo obvious. Pero ni-shift siya upward. Kani ni-shift siya more upward. Shift downward, I think. Lagay downward. Wala. So, mali lang mga origin. Kung gusto na to i-derive yun sa pagkuha ng pag-obtain ng mga signal, KVL gyapon ang tool. So, maling origin sa original signal. If you'd observe, very complicated ng mga circuits, pero ang naitabo lang yun, is either ni-shift lang yun siya upward or downward. Alam niyo ang direction, no? Yan na. Walay clipping na itabo, walay removal of the signal na itabo. It's just, no? Shift upward or downward lang. Okay. So we'll end here. Zener diodes will be discussed next meeting. But with regard to rectifiers, clippers, and clampers, any questions?